Welcome back to Foundations of Visualization. I'm Professor Danielle Albert-Safer, and for this lesson, we're going to jump into a series of lectures and activities that will give you some hands-on experience using Altair, a Python library for creating interactive and expressive visualizations within Jupyter Notebooks. If you're not familiar with Jupyter Notebook, I would highly encourage you to check out either some of the other lectures in this program or to check out some of the tutorials online to get just some basic familiarity with creating and running a notebook before jumping too much more deeply into these materials. Today, we're going to start with just a high-level overview of what Altair is and some of the fundamental assertions around how it works. And then in the next two videos, we'll look at a few of the basic functions that you can use to work with Altair. There's also a Jupyter Notebook available to complement these lectures that will give you a little bit more of a hands-on tutorial for how to work through some of the basic expressive functions of Altair that will give you a little bit more creativity and flexibility in terms of how you tackle implementing many of the ideas that we're going to talk about in this course. So Altair builds on this fundamental concept that we talked about in our last lecture called the grammar of graphics. As a quick refresher, the grammar of graphics divides every visualization into its data, so what information is being passed into the visualization, its aesthetics, what visual elements do we see as part of that visualization, its scales, how do we map from data to the visual, geometric objects employed, so think of this as, are we using lines, are we using bars, are we using points? The statistics we use to pre-process our data before showing it, are we showing the raw data, are we showing averages, are we showing regressions or trends? The facets that we divide our data into, what dimensions or subsets do we choose to show? And the coordinate systems we use. And typically speaking, these are going to be our linear Cartesian coordinates or polar coordinates, though you will occasionally see examples that use less conventional coordinate systems. And the reason that we focused on the grammar of graphics is that it underlies several common visualization toolkits, including Altair. So Altair is a Python library that's used to create JavaScript visualizations. It's essentially a wrapper around a library called Vega Lite. So if you've ever used Vega Lite before, much of what we're going to talk about through the course of this lesson might feel quite familiar. And Altair uses a declarative structure that's built on the grammar of graphics. Essentially what we can do is we can explicitly bind different attributes of our data set to different elements of our visualization using the grammar of graphics as a framework for specifying those bindings. Once we've done that, Altair uses the browser's ability to render interactive imagery and content to build visualizations in our notebooks. And part of the power of using this web-based renderer is that we can turn around and export our visualizations for use in the browser. So we're not necessarily just bound to keeping our visualizations in our notebooks, but we can actually export functional SVG or scalable vector graphic specifications of our visualizations in JavaScript that can then be imported into external web pages for example, online exploration or online communication of our data. So what does a basic Altair chart look like? Well, we start off by importing our data, and then once we've done the data import, and if you'd like additional data wrangling, we can go ahead and draw our chart. So the two cells we see here are all the code that we need to draw the bar chart on the left, and we'll get a little hands-on with this in our next video. But the basic idea is that here we're using Altair to work with pandas data frames. If you're not familiar with pandas, the basic idea is it is a simple to use statistical toolkit that functions within Jupyter Notebooks. And what we do in this top cell is we simply import the pandas library and we use pandas CSV reader to read the data from an external CSV into a data frame. Once we've read in that data frame, we can bind that data frame to a chart and start to specify different elements from the grammar of graphics that will change and indicate how our data is translated into our visualization. So the basic structure of an Altair code is essentially a series of functions joined by dot notation. So typically this looks something like starting with our data binding, then specifying our geometry, then specifying aspects of our aesthetics, faceting our data, and integrating additional interactions. When we talk about aesthetics in the context of Altair, we can specify things like our scales or our statistics on a per data dimension. So this allows us to, in the context of specifying what elements we bind to which visual channels, also specifying the scales that we use to do that binding and the statistics that we want Altair to compute as part of that binding. One of the other powerful things that we can do with Altair that you'll see in our third video is that you can actually pipe together different charts to try to facet the data. Altair also offers a number of custom functions for faceting the data along the lines of different dimensions or along specific subsets of our data. And you will see some of these in the accompanying Jupyter notebook. So as I mentioned at the start of the video, there's a little homework for getting started on these activities. First, you want to make sure that you've installed Python and Jupyter Notebook. If you've already done some of the other courses in this program, you probably are ahead of the game here. Then you'll also want to make sure that you install Altair. And there are directions for doing this on the Altair website, which is altair-viz.github.io. If you're already comfortable with using the command line for Python installations, you can install Altair using either pip or conda, depending on the base installation package that you're using. With that, in our next lecture, we will get hands-on with doing a little bit of live coding of some of the basics of Altair. I'm looking forward to working with you all then.